Right now, I'm going to generate 100 circles in Grasshopper. Ready? Watch. One slider change 100 circles. No copy, no paste, no loop, no code. That happened because of list. And once you understand list, Grasshopper starts feeling like a superpower. I am Ajit Kumar. This is day 5. Let me show you exactly how that worked. Before we touch the screen, let me give you a mental model for today. Think of a spreadsheet. Column A has 50 numbers in it. You apply a formula to the entire column. Every cell gets processed simultaneously. You do not apply the formula 50 times. You apply it once to the whole column. Grasshopper works exactly the same way. In Grasshopper, a list is that a column of values. When you connect a list to a component, the component runs on every item in the list at the same time. Result, you get a list of outputs. One component applied to 50 inputs gets you 50 outputs. That is a core parametric efficiency. Until today, everything you have done in Grasshopper has worked with a single value. One number, one point, one circle. Today, we switch the factory from making one product at the time to running the entire production line in parallel.
The easiest way to create a list of numbers in Grasshopper is the series component. Double-click the canvas, type series, place it. Series has 3 inputs. S. Start the first number in your list. N. Step. How much to add each time. C. Count. How many numbers to generate. Let me show you what it does. Place 3 number sliders, one for each input. Connect start to S, step to N, count to C. Now, let's see what this list contains. Place a panel to the right of the series output. Look at the panel. Start 0, step 3, count 5. We get 0, 3, 6, 9, 12. 5 numbers starting at 0, each 3 more than the last. Change count to 10. Now we have 10 numbers. Change step to 1. Numbers 0 through 9. Change step to 10. Numbers spread further apart. The series component is just a recipe. Start here, jump by this much, make this many. Simple. Now, here is where it gets powerful. Let us connect this list to the construct point component. Place a construct point to the right of the series. Connect the series output to the X input of construct point. Look at Rhino. 10 points, 1 construct point component. We gave it a list of 10 X values, it made 10 points. The component ran 10 times in parallel automatically. Drag the count slider to 50. 50 points, change count to 100. 100 points, all from one series, one construct point and 3 sliders. Now, let's put a circle on every single one of those points. You will need an XY plane and a circle component. Watch Rhino. One circle component, one radius slider, 100 circles. Change the radius slider. All 100 updates at the same time. That single slider controls every circle in the definition. This is parametric efficiency. You change one rule, everything follows. Now, let me introduce our second list generating component, range. It works differently from series. Instead of a start, step and count, range takes a domain and divides it evenly. Range has two inputs. D, the domain. This is the start and end of your number range. N, the number of steps, which gives you n plus 1 evenly spaced values across the domain. The output is always values evenly distributed from domain start to domain end. So the domain of 0 to 10 with 4 steps gives you 5 values: 0, 2.5, 5, 7.5 and 10. Range is perfect when you know the total span you want to cover and you want even distribution. Series is perfect when you know the spacing and you want to count up. Two more essential components for working with list. First, list length. Connect the series output to list length's L input. A panel on its output shows a single number, a count of items in the list. This is exactly equal to your count slider value. Very useful when your list come from a complex chain and you have lost track of how many items are in them. Second, list item. Connect the series output to list item's L input. List item has two inputs, L, the list, and I, the index. The index is the position number of the item you want. And here is the rule that trips up almost every beginner. Grasshopper counts from 0. The first number in any list is at index 0. The second number is at index 1. The third number is index 2. This is called zero-based indexing. If your list has 10 items, valid index values are 0 through 9, not 1 through 10. Set the index to 0. You get the first item. Index 1, you get the second item. Index 4, you get the fifth and the last item. Index 5 on a 5 item list, error. You have gone out of bounds.
Today's exercise uses everything we just covered. We are going to make a row of circles where each circle has a different radius, growing from left to right.
Start with a series. Start at 0, step at 3, count at 5. Connect to x input of construct point. You have 5 points in a row. Now add xy plane and circle as before. But this time, instead of single radius slider, connect a range component to the circle R input. Place a construct domain component. Double click canvas, type construct domain, place it. Connect a slider with value 1 to the A input. This is the minimum radius. Connect a slider with value 6 to the B input. This is the maximum radius. Now place a range component. Connect construct domain output to range D input. Connect a slider value 4 to range N input. Range N equal to 4 gives us 5 evenly spaced value from 1 to 6. Connect range output to circle R input. Look at Rhino. 5 circles, 5 different radii, growing from 1 to 6 from left to right. That is attractor based thinking in its simplest form. A changing input creates a gradient of geometry.
That is day 5. List, series, range, list length, list item. The factory now runs in parallel. One input list feeds a component. The component runs once every item. You get a list of outputs. That mental model is the foundation of everything we build from phase 2 onwards. Tomorrow, day 6, we work with curves. You will draw a freeform curve in Rhino, bring it into Grasshopper, divide it into equal segments and place geometry at every division point. The result looks like a real architecture rib structure. Subscribe to catch day 6. See you tomorrow.